For more than 4 decades, Voyager 1 has journeyed outward, carrying with it not just instruments and sensors, but also humanity's oldest dream, to step beyond the horizon. When it launched in 1977, its mission was modest in scope: to fly past Jupiter and Saturn, sending back images and measurements that would change how we see our own neighborhood in space. But Voyager did more than anyone expected. It became the first human-made object to cross into interstellar space, farther from home than any other machine in history. More than 15 billion miles away, its faint radio signals still threading back across the void. What it has discovered at this frontier has stunned scientists. For decades, astronomers assumed the boundary between our solar system and the wider galaxy, called the heliopause, was calm, almost like a shoreline where two oceans meet quietly. The solar wind, a constant stream of charged particles flowing from our sun, was thought to push against the thin gas and plasma of interstellar space, creating a smooth dividing line. Voyager 1's data, however, shattered that picture. Instead of calm, the spacecraft revealed turbulence, a restless, storm-like boundary where forces collide. Waves of plasma surged and shifted, magnetic fields tangled and snapped, and high-energy particles raced through gaps like arrows through cracks in a shield. This outer frontier was alive, changing not on geological or astronomical timescales, but in days and weeks. It was like watching a heartbeat at the very edge of the solar system. Among the most remarkable findings were the plasma oscillations. Voyager's instruments picked up faint vibrations, not sound in the traditional sense, but shifts in charged particles that could be translated into a low, cosmic hum. This meant that space itself at the boundary was resonating, alive with hidden rhythms. Scientists realized that our solar system is not sealed off like a fortress, but is constantly exchanging matter and energy with the galaxy around it. Every surge of solar wind, every incoming wave of galactic plasma, leaves its imprint in real time. This discovery has profound consequences. The heliosphere, once thought of as a protective bubble, turns out to be porous and dynamic. Cosmic rays, particles accelerated to near light speeds by violent events like supernovae, may find easier pathways inside. These rays have the potential to influence not only spacecraft systems, but also Earth's atmosphere and even biological processes. While our planet's magnetic field and atmosphere provide strong protection, subtle variations in cosmic radiation could ripple through climate systems or evolutionary history over vast spans of time. Voyager also revealed something even more startling: the interstellar medium itself is not empty, but structured. Instead of a void, it is filled with flows of particles, waves of pressure, and faint currents, shaped by the deaths of ancient stars that exploded as supernovae millions of years ago. These events left scars and echoes across the galaxy, and Voyager is now sailing through them, sampling the aftershocks of cosmic history. Even the magnetic fields Voyager encountered behaved in ways no one predicted. Rather than bending smoothly, they twisted and reconnected, suggesting the existence of vast, hidden structures, some larger than planets, that channel cosmic energy through the galaxy. These processes could be the very reason why cosmic rays are able to slip through the heliosphere's defenses, carried along invisible corridors of magnetism. What Voyager found is not just about our own sun. Every star, from the smallest red dwarf to the most massive giant, carves out its own bubble in the galaxy. These stellar bubbles press against one another, forming a vast, interconnected mosaic across the Milky Way. Voyager's discoveries suggest that our solar system is not an island adrift in emptiness, but a thread woven into this larger galactic fabric. We exist inside a network of forces, a tapestry of stellar winds, cosmic rays, and ancient energy, stitched together over billions of years. For NASA, the significance of these discoveries is doubled by the improbable hero of the story, Voyager itself. Imagine it. A spacecraft built nearly half a century ago, designed in an era when computers filled entire rooms and data still traveled on magnetic tapes. Voyager carries less computing power than the average wristwatch. Its memory would be too small to hold even a single modern photograph. And yet, against all odds, this fragile probe continues to whisper across the abyss, powered only by a fading nuclear battery and a transmitter no stronger than a household light bulb. Every signal it sends back must travel more than 15 billion miles, taking over 22 hours just to reach Earth. Each faint pulse of data must be caught by giant radio antennas, amplified, decoded, and pieced together into meaning. And still, those signals carry revelations that reshape how we see not only our solar system, but the galaxy itself. That such a modest machine, crafted with the tools of the 1970s, could reveal the living edge of the heliosphere is nothing less than one of the greatest triumphs in the history of exploration. But Voyager's discoveries reach deeper than science alone. They force us to rethink our very place in the cosmos. For generations, we imagined the solar system as a safe harbor, sealed off from the chaos of the galaxy by the sun's invisible shield. The edge of the heliosphere was thought to be a barrier, marking the end of our sun's influence, a quiet shoreline beyond which lay only distant stars. Voyager has shown us that this picture was an illusion. The boundary is not a wall but a restless frontier, bending and flexing under pressure, breathing like a living organism. The sun's reach, vast as it is, cannot hold back the galaxy's tides. Instead, our solar system is part of something larger, an ongoing dialogue between stars. Every stellar wind, every burst of plasma, every ripple of magnetism joins a chorus of cosmic forces that echo across the Milky Way. We are not separate from this greater system. We are embedded within it. And so, Voyager 1 offers us a new vision of exploration. It reminds us that the universe is not neat, predictable, or quiet. It is turbulent. It is layered with complexity. It is filled with structures we are only just beginning to glimpse. Through the spacecraft's faint voice, we hear not just science, but something more, a call to humility, a call to wonder. This tiny probe, no bigger than a small car, has crossed into a realm where no other human-made object has gone. It is alone, surrounded by silence deeper than any we can imagine, and yet it continues to speak. Its message is clear. Even at the farthest frontier, there are surprises waiting to be found. The edge of the solar system, once imagined as an ending, has become instead a beginning, a gateway into mysteries larger than our sun, larger than our world, larger even than our imagination. Voyager shows us that the story of exploration does not end at the boundaries we once drew. Beyond every horizon lies another, waiting. And as long as that faint signal continues to arrive, as long as Voyager's voice carries across the dark, humanity will have a connection to the stars. A reminder that no matter how small we are in the face of the galaxy, we are capable of reaching across it. Capable of learning. Capable of wonder. In the end, Voyager's journey is not just the story of a spacecraft. It is the story of us, a species that dared to send a message into the unknown, and in doing so, discovered that the universe is far stranger, far richer, and far more alive than we ever dreamed.